Hello, good afternoon. Hello, hello,
Good afternoon, sir.
good afternoon. So last time कितने slides miss हो गए थे? मुझे बताइए कहाँ से लेना है हमको? यहाँ से? हेलो, हेलो. Could you just tell me where we missed the slides? Hello. So I will start. I'll start from start. I will revise it. Okay. So ARM Holdings is a company that develops a processor that is system on chips and software. ARM was founded as an advanced RISC machines in 1990 as RISC is the main CPU design strategy implemented in its processor. Today, ARM processor is almost in every domain that is handheld devices, consumer electronics, robotics, automation, etc. Processor developed from ARM IPs are used in embedded systems like smart TVs, smart watches, smartphones, tablets, computers, etc. Then advanced RISC machines are defined as a family of CPUs that have wide usage in electronic devices such as smartphones, wearables, tablets, and multimedia players. The ARM core is specially been designed for the embedded system as it satisfies the features of RISC and CISC together. It's not a pure RISC, and it's a blend of RISC and CISC features. So now let us see what is RISC. It's a reduction instruction set computers. So it is having an instruction set architecture, and this ISA is the medium processor where the processor communicates with the human programmer. An instruction processor to perform an action. So when an instruction set is there, it means the entire collection of the instruction for the processor is taken into consideration. And instruction set is nothing but the entire collection of instructions for given processor, and the architecture is nothing but what particular way the system is built to make the processor. Then let us see what RISC says. Its main idea behind it is to make hardware simpler by using instruction composed of few basic steps like loading, evaluating, and storing. So basically, RISC is what is happening is that for each and every step, you have to give an command. You have to give an command for each and every step to get executed. But in case of CISC, it's a complex instruction set computer in which a single instruction is given, and all the steps like evaluating, storing, or loading will be executed at a time. Evaluating and storing it here is little complex, and hence it is called as the complex instruction set computer. Then we'll say that ARM core gives a lot of benefits to the embedded systems. The first one is a high performance. Second is a low power consumption, low silicon area that reduces the site and consumes less power, high code density that is for having less memory footprints, load store architecture used to load the data from memory or from CPU to memory or from memory to CPU that enables the memory access whenever required. Now register bank, so it is a bank of registers that is been used to perform most of the operations in CPU, and it also having a context switching between the multitask applications. So this is the basic ARM architecture. So you can see the address register, register bank, incrementer, then you register multiplier, then barrel shifter, having buses like A bus and B bus, then data out register, data in register, and the control section, which is an instruction decode and control, which is done after fetching the instructions. So the ARM Cortex M3 can be understood only if you understand ARM processor and its architecture, having the register bank of up to 16, that is R0 to R15, having a program status register, then having 20 numbers banked registers which are invisible for the users. It is having 2 read ports and 1 write port in order to get the result back specified by the instruction, and it has an additional bidirectional port to update the program counter with address register as an increment. The address register is incremented at every sequential byte accessed by the incrementer. So as soon as the operation is carried out, it moves to the next register, then incremented to the next register. So it is incremented by 4 steps if it is in ARM state, and it is incremented by 2 steps if it is in thumb state. The address register is directly connected to address bus. The barrel shifter can shift or rotate the operand by specified number of bits prior to arithmetic or logical operations. The 32-bit ALU performs arithmetic or logical operations. The data in and data out registers hold the input and output from and to memory. The instruction decoder is used to decode the signals, control the signals for the data path after decoding the fetch instructions. So it is going to fetch the instructions, then decode it, and then it is going to have a control over the things. Then the MAC unit is to multiply 2 register operands and accumulate another register for holding the products. So the 2 operands will be 1 through plus 3, and then the result will be holded in the another register. The encoded instruction byte of the programs are saved in the code memory, is fetched through data bus and enters into the data register for ARM architecture. From it is delivered to the instruction decoder. After the instruction is decoded, appropriate control signals are generated for the data path. The required registers are activated in the register bank, and operands low out from 2 read ports of the register bank to the ALU. So I said that if there are 2 operands A and P, so the first operand will be read, second operand will be read, the operations will be carried out, and then the third will be stored into the third will be through the write operation, write port, it will be stored into operand 1 from A bus and operand 2 from B bus after pre-processing at the barrel shifter. Then this is the architecture. The result of the operation of ALU is written to the result register through write port. So I said the same thing. I said that when reading with the 2 read ports and writing the results with a 1 write port. For load store instruction, after decoding the instruction, the data memory address is first calculated at ALU as specified in the instruction, and pointer register is updated in the register bank. The address in the pointer register is given to the address register to access the memory and transfer data. If it is a load multiple or store multiple instruction, the code does not halt before completing the required number of data transfer unless it is reset. So it will execute the operation unless and until it is halt through the reset exception. So this is the Cortex M Cortex series classification. So 3 types of Cortex series is there. One is Cortex A, Cortex R, and Cortex M. Cortex A is used for the advanced operating system and exhibits the highest possible performance. Cortex R, actually it is used for real-time applications in order to get the faster response time, and M is mainly built for the microcontroller. So now we are going to see the highlights and main characteristics of ARM type of the processor. Then this is the series application. You can see that there is an M0 to M4. Then the R Cortex RX is given by R7, R5, R4. Then Cortex A5, A7, A8, A9, A15. So A series, M series, as well as the R series you can see from here. So the Cortex A5 to A57 is from Cortex A application. This is a high-speed performance, full OS support, smartphone, digital TV. Then Cortex R is a real-time processor, which is used for real-time applications, high performance, automotive braking systems, etc. And Cortex M is specially built for microcontrollers, cost-effective solution for the microcontrollers. Then the Cortex A category is specially dedicated to Linux and Android devices. The examples are smartwatches, tablets, and various network equipments comes under Cortex A. So Cortex ARM 7A architecture is having A5, A7, A8, A9, A12, A15, and A17 processors, and it is a top performance. It gives a top performance with a brilliant power efficiency. Then under which A5 is a small processor, but it still demonstrates the multi-core performance. A7 and A5 are mostly the same, whereas A7 is somewhat 20% higher in performance as compared to A5. It is also famous for its power optimization technology. Applications include smartphone, tablets. A15 processor finds its application in high-end devices, low servers, low power servers, and wireless technologies. This is the first processor in the range that fits data management and virtual environment solution. The effectiveness of the Cortex A17 is impressive as it is satisfying the need of premium class devices. A15 is the latest in the series and can be used in the area of applications like low power servers. It demonstrates power optimizing feature and a great condition of migration of 16-bit operating system to the mobile solutions. Applications of Cortex A series, smart devices and wearables, automotive systems, servers and networks, satellite receivers, home gateways. So is it okay? The first one is clear now, students? Hello?
Yes, sir.
हाँ, ये यहाँ तक का पूरा क्लियर हो गया, समझ में आ गया? हेलो?
Yes, sir.
Okay. So now we'll move towards the next part of the introduction to ARM. It is basically very important as far as the embedded systems are concerned as well as IoTs are concerned. So normally embedded and IoTs go work in hand to hand, and that's why we need to understand this ARM Cortex M3 series. So now we'll move towards the ARM Cortex R series. After seeing the A series, this is the Cortex R processor. Primarily that has been useful for real-time solutions, and they find a lot of applications in controllers, network equipments, media players, and other similar devices. Furthermore, this type of ARM processor provides great support for automotive industry. Then Cortex R processor have a lot in common with high-end microcontrollers, but at the same time have the ability to fulfill their scalable tasks. So this is the R series. So remember one thing, that R series is for the real-time applications, and this real-time applications is used because the applications wants a faster response. So faster response time, for that purpose this R series is used. First one is an R4. It can be clocked to 600 megahertz. Its main characteristics is dual issue 8-stage pipeline and prefetch condition. R4 controller can quickly handle any incoming interruptions. Then R5, this type of processor takes care of networking and data storage. It extends the set of R4 features by adding improved efficiency. So R5 and R4 are actually same, but with some of the advanced features in R5. It deals with error management and enables fast peripheral reading and writing. The dual core implementation of Cortex R5 allows the construction of a strong system with lightning fast response. So as far as real time is concerned, it gives a lightning fast response. Also, it switches between the multitask applications very easily. Then comes your R7. The processor from this category demonstrates very high performance. Tools can be implemented for lockstep, symmetric, and asymmetric multiprocessing. The generic interrupt controller is another significant feature, so that should be mentioned. So this is R5, R7. Now after R series, we have a Cortex M series, and I do feel so we are going to concentrate on this series. So in this series, we are going to see M3 series, which is by far the advanced series. But before that, we should understand how this ARM Cortex M series work out. Actually, why it is having the advantage? Because it follows the industry standard, and henceforth it can be used in different applications. The ARM processor of this type find their implementations in FPGA, integrated memories, and clocks. Each of the designed controllers is used to a particular segment of the market. I said that because of the industry standard, it is used in a particular segment. The Cortex M processor family is more focused on lower end of the performance scale. They are still powerful when compared to most microcontrollers. Example, M4 and M7 are used in many high performance microcontroller products with minimum clock frequency of up to 500 megahertz. The performance is not only the factor while selecting this processor, but in many applications, low power cost is also important. And therefore, Cortex M series contains variable products to address different needs. So, according to the different applications, different need, this Cortex M series can be used. And it is mostly following the industry standard, hence, it's been useful in industrial applications also. Now, Cortex M0, so we'll be having the subtypes in it. So a very small processor for low cost, ultra low power microcontrollers and deeply embedded applications. Then Cortex M0 Plus, the most efficient processor for small embedded systems with additional features like single cycle IO interface and vector table relocation. Cortex M1, a small processor designed optimized for FPGA designs, same instruction set as Cortex M0. Then comes Cortex M3, a small but powerful embedded processor for low power microcontrollers, having a very rich instruction set to enable the complex task quicker. Now see, we have to concentrate on this Cortex M3 because we are going to study this Cortex M3 in detail. So why this Cortex M3 is being used? Because it's a small microcontroller, but it is very powerful embedded processor. But it is a very powerful embedded processor. It can be used. And low power microcontrollers that are rich in instruction set and handles the complex task easier. That is the most important thing of Cortex M3. It has a hardware divider and MAC, that is multiply accumulate instruction set. In addition, it also has a comprehensive debug and trace features to enable software developers to develop their application quicker. So this is by far the most important M series Cortex. Then M4, it provides all the features of Cortex M3 but with additional instruction target at DSP such as single instruction multiple data and faster single cycle MAC operation. Then a high performance processor for high end microcontrollers and processing intensive applications. So this is the M1, M3, M4, M7. Now M23, a small microprocessor processor for ultra low power and low cost designs similar to Cortex M0 Plus, but with various enhancement in instruction set and system level features. It also supports the trust zone security extension. So it is added, this Cortex M23 is similar to Cortex M0, but this trust zone security extension has been there added. So they have provided some security features. M33, a mainstream processor designed similar to M3, Cortex M4, but with much flexibility in the system design, better energy efficiency, and high performance. It also supports trust zone security extension. So it is also having the trust zone security. Now we'll go with the overview of the Cortex M3 processor. Now here we have to see that how this how this M3 processor works out to be. The ARM Cortex M3 processor is the first in the Cortex generation of the processor released by ARM in 2006 and was primarily designed to target a 32-bit microcontroller market. It provides an excellent performance at low gate count and comes with many new features which is previously available only in high end processors. तो जो पहले के माइक्रो कंट्रोलर्स थे उसमें जो फीचर्स थे हाई एंड प्रोसेसर्स के लिए वो इसमें आ गए हैं totally. So it becomes a very boostable kind of processor. It boosts different features. Cortex M3 addresses the requirements of 32-bit embedded processor market in the following ways. So what are the specialities of this Cortex M3 processor? We'll see it in different ways. First is the greater performance efficiency, allowing more work to be done with increasing the frequency and power requirement. Then low power consumptions, enabling longer battery life, especially in portable products where you have an wireless networking applications. Then enhanced determinism, so guaranteeing the critical task and interrupts are serviced as quickly as possible and in no number of cycles. Improved code density, it ensures that code fits in even the small memory footprints. So you can see that most of the time what happens, your code is too large and it requires huge amount of memory to execute it, to store it. But in this case, you can they are having this code density improving feature, which actually helps to fit the code in the smallest memory of the footprints. Then ease of use, it can be easily programmability and debugging for growing number of 8-bit and 60-bit users migrating towards a 32-bit. So an updation of this microcontroller can take place from 8-bit, 16-bit to 32 bits. It is having low cost, and second is wide choice of development tools. Cortex M3 processor based microcontrollers can be easily programmed using C language as well as based on established architecture. Application code can be ported and reused easily, reducing the development time and testing cost. So obviously it can be programmed very easily using C language. So see what happens is that on which platform you're going to write the program becomes very important. So if it is supporting C language, that means it's quite easier, and you can you're having the choice of developing the tools with the help of C language. So reducing development time and testing cost is also one of the best features of M3 processor. Now comes the instruction set of Cortex M3. So we have already said that instruction is nothing but the command that is given to the processor for the response, and the instruction set is nothing but having number of instructions working together in an instruction set. Two different instruction sets are supported by the ARM processor: ARM instruction that are 32-bit and thumb instructions that are 16-bit. So in this, you have to remember two instruction sets. One is your ARM instruction set and the other one is thumb instruction set. The ARM instruction sets are for the 32 bits and thumb instruction sets are 16 bits. During program execution, the processor can dynamically switch between the ARM state and thumb state. So this is one of the beautiful feature, that it can switch between two states to use either one of the instruction sets. You don't need to have to use both the instructions at a time and then use it. You can just shift it over from this to this. The thumb instruction set provides only a subset of the ARM instructions, but it can provide higher code density, and it is useful for the product with tight memory requirement. Now we are going to understand the thumb 2 technology and instruction set architecture. So if you go by previous, there is an ARM instruction. See, look at the ARM instruction that is 32-bit and thumb instructions that are 16-bit. So you can see that the inside circle is a thumb instruction. Then they will be having an ARM instructions. So that dot dot kind of circle is through the ARM instruction, and the thumb 2 technology, 32-bit and 62-bit thumb instruction set is outside. So if you're using thumb 2, that automatically you're going to have an inbuilt Cortex M3 plus thumb instructions. So this is most important, that the thumb 2 technology can be very useful in this case. So the thumb2 technology extend the thumb instruction set architecture, so ISA, into a highly efficient and powerful instruction set that delivers significant benefit in terms of use, code size, and performance. So you can see the figure. It is the relationship between the thumb instruction set in thumb2 technology and the traditional thumb. The thumb 2 technology in instruction set architecture is a superset of the previous 16-bit thumb instruction set with additional 16-bit instruction set along the 32-bit instruction set. So thumb 1 के अंदर देखा जाए तो 16-bit instruction set है, thumb 2 में 16-bit instructions along with the 32-bit instructions. So you can really shift in both the sides. It allows more complex operation to be carried out in thumb state, thus allowing higher efficiency by reducing number of states, switching between ARM state and thumb state. Focused on small memory system devices such as microcontrollers and reducing the size of the processor. The Cortex M3 support only thumb 2 and traditional thumb instruction set. So obviously, if thumb 2 is being supported, you can support the traditional thumb instruction also. With support for both 16-bit and 32-bit instructions in thumb 2 say instruction, there is no need to switch the processor between thumb state and the ARM state, that is 32-bit instructions. The Thumb2 instruction set is very important feature of ARM7 architecture. The Cortex M3 processor instruction set has large number of new features. For the first time, hardware divide the instructions is available on an ARM processor, and number of multiply instructions are also available on Cortex M in order to improve the data crunching performance. So this kind of feature is very, very important for Cortex M3. That is, the hardware divide the instructions is available on ARM processor, and a number of multiply instructions are also available. It also supports the unaligned data access, a feature previously available for only high-end processors. उसमें जो unaligned data access पहले नहीं होता था, क्योंकि वो aligned properly होता नहीं है, उसको पहले processing करनी पड़ती है. So what happens is that even it accepts the unaligned data access. So I do feel, so once again I'll revise the, okay. Right. See, the Cortex R series is for the real-time applications. Okay, simple one. This is for real-time applications. It can be used for fastest, quicker response time. Then it has a lot of high-end microcontrollers, but at the same time, ability to fulfill the scalable task, in which we are using R4, R5, and R7. Then Cortex M series actually is known for its standard industry standards. They can be implemented in FPGA, integrated memories and clocks, easy of design controllers to use a particular segment of the market, and they are more focused on lower end of the performance scale. Minimum clock frequency up to 500 megahertz. Then M series, which has been suitable for the microcontroller, and it is not only factor which depends on the performance, but also in many low power applications are also important. So Cortex M0, Cortex M0 plus, Cortex M1, Cortex M3. Now M3 is very much rich in instruction set and can handle a complex task easier. It is also has an hardware divider and MAC instructions, which can be useful for the software developers to develop the application quicker. M4 and M7, high-end microcontrollers and processing intensive applications. Then M23, it is similar to M0 plus, but having a various enhancement in instruction set. M33, one special feature having trust zone security. Then overview of Cortex M3, greater performance efficiency, then low power consumption, enhanced determinism, improved code density, ease of use, low cost, wide choice of development tools. So the most important is that it can be easily programmed using C language, and they are based on well established architecture. Application codes may be ported, reused easily, and reducing development time and testing cost. This is the very beautiful feature, like your can be reused easily and reducing the development time and testing cost. Then instruction set of Cortex M3, it is having two kind of instructions, the ARM instructions and the thumb instructions. So the advancement of the thumb instruction is the thumb2 instruction. It can easily switch between the ARM state and thumb state. So it can easily use one of the instruction sets. It is useful for products with tight memory requirement. So this is the thumb2 kind of technology. So you can see that the thumb2 includes the traditional thumb instruction set and ARM set, and thumb2 itself is having a 16-bit along with the 32-bit. So you can see that with additional 16-bit instruction alongside of 32-bit instructions. So it allows more complex operations to be carried out in thumb state, focused on small memory system devices such as microcontroller and reducing the size of the processor. With the support to both 16-bit and 32-bit instructions in thumb2, there is no need to switch the processor between thumb state and the ARM state. So thumb state is 16-bit, ARM state is 32-bit instruction set, and when it goes to thumb2, it could be 16-bit along with the 32-bit. So thumb2 instruction set is one of the important features. It has large number of new features and available for the hardware divide instruction is also available for the ARM processor, and it also supports the unaligned data accesses a feature previously available only in high-end processors. So this is the chapter. This is the point which we have covered today. So have you got this, students? Hello, hello, hello.